relations, domain, and range. A relation is just a set of ordered pairs. So here we have a relation. 1, 1, 1, 2, 3, 4, 4, 6. It's just coordinates. That's all it is. And here's another one. Every relation has two sets. It's got the domain, so the x values, and it's got the range, the y values. So for the above, the domain for the S is 1. We don't need to repeat this one. 3 and 5. So 1, 3, and 5. While the range is 1, 2, 4, and 6. 1, 2, 4, and 6. While for T, the domain is -3, 4, 5, and 7. -3, 4, 5, and 7. And the range for T is the 5, the 12, don't need to repeat the 12, and the -6. So I'm going to put them in order. So -6, 5, and 12. Now some relations are defined by a rule. And again, we can do the domain and range. So for this set, y equals x plus 1, we have the rule 1, 2, 3, 4. It's only those points, 1, 2, 3, 4. When you put x into the rule, x equals 1, you get 2. So you get that point. When you put x equals to 2 in there, you get 3. And so on and so on. The domain is still the 1, 2, 3, 4. The range is the 2, 3, 4, 5. Cartesian graphing relations. We graph them on an x and y Cartesian, just same as before. So this one here says graph the relation y equals x plus 1 when x is 1, 2, 3, 4. So if I was to draw this, I'd be putting x is 1, 2, 3, 4, and y 1, 2, 3, 4, 5. And all it's going to be is dots. 1 and 2, 2 and 3, 3 and 4, 4 and 5. So that's what that is. The domain is still going to be 1, 2, 3, and 4. And the range for this one is going to be 2, 3, 4, and 5. The squiggly brackets. But if we had the reals, then we get this type of graph, which is our straight line. Okay, so that's the real values because it includes all the x values that there is. So there's the difference between them. We can map them when we say mapping them. A map is just right. We're going to write all the domains here. So 2, 1, 2, 3, 1, 2, 3. So, and then we're going to show an arrow as to where they can go. And the range that we can take are 2, 4, 5, and 6. So 2, 4, 5, and 6. So 3 goes to 6, and I'll do it in a different colour. 3 goes to 5, 2 goes to 5, 2 goes to 4, and 1 goes to 2. So that's our mapping diagram. Okay, so remember, a relation has to be written, has to be a listed set of ordered pairs, not always possible or convenient, a rule with a specific implied domain, and it can be represented as a graph or a mapping diagram. So example 3 is sketch the graph of each of the following and state its domain. So again, these are just points for part A, which I'll try and sneak in here. We've got to go x is -2, y is -1. So -1, -2, -1, 1. So when I do this one, I'm going to get -2, -1, which is down here, -1, -1, -1, and a +1, 0 and 1, and 1 and -1. So there we go, that's that one there. While for B, we have x squared plus y squared equals 1, so a circle between 0 and 1. So the element, all the numbers between -1 and 1. So this will become, when we do it, 1 and -1. It's just a circle like this. That's my y-axis, that's my x-axis. B, I'm trying to write on screen, that's a little bit harder. C, this one here is just a straight line, we can see it, and we just want the positive x values. So don't bother even trying to do any of the negative x values. So when I put x equals to 0 in there, I'm going to get y equals 2. So there's 2. I'm just going to quickly do this. When I put x equals 1, I'm going to get 2 times 1, which is 2. Take it away from the other one. 6 minus 2 is 4. So 1, and so it's going down like this. So there's my graph. Okay, and I'll come back and do the domain and range for each of them. D, and I can find the x-intercept to put y equal to 0. This is going to be 3. Okay, but it's going to continue. D, we have y equals minus 2x minus 1, but we only want it between negative 1 and 2. So when it's negative 1, we put negative 1 in here. We're going to get 2 times negative 1 minus 1. So negative 2 minus 1, which equals negative 3. So we go all the way down here to negative 3. That is a point there. And then we want to 2. So we can do 0 as well. Put 0 in there. You're going to get negative 1. So it's going to cross there. And then when you put x equals 1, you're going to get 2 minus 1, so 1. So up here, when x is 2, 4 minus 1, which is 3. So 1, 3 there, and we get in this straight line like this. And it stops, because these ones only go from there. So for the first one, I won't do domain and range for the first one. For B, domain is going to be, you can write it like this: negative 1 less than equal to x less than equal to 1, because it includes all those from negative 1 to 1, and the same with the range. Negative 1 less than equal to y less than equal to 1. You can write it differently. Here, the domain, well, they give it to you. The domain is x being greater than equal to 0, while the range is going to be from 2 all the way down negative. So the range is y less than equal to 2, because we include 2 and then keep going towards a negative 1. This one here, the domain, they give it to us, and the question is an element. You can write it like this: negative 1 to 2, while the range for this one, the smallest value of the y is negative 3, and the biggest is 3, so we can go element of negative 3 to 3 inclusive, so we put the square brackets. Find the range of the relations with these rules. So it's easy just to work them out, like factorize it. So I'm going to factorize this, and I'm going to get x minus 5 and x plus 1. So x equals negative 5, that's where it's crossing. So it crosses at 5 and negative 1. So we really need the turning point here, because the graph looks like this. We need to find the turning point. So the turning point, x equals minus b divided by 2a to get the x value. So I'm going to get 4 divided by 2, so the x is 2. When x is 2, y equals 4. Substituting back in, so 2 squared is 4 minus 8 plus 5. So we've got 9 minus 8, which is 1. So this, how can we have that? 4 2s are 8. Negative 2, positive 8, so 12, 17. So this point here, I've done something there, and I can't see it, but it should be halfway between that. Negative 5, 5 minus 1 for 2, x is 2, 2 squared is 4. I can't see it at the moment. Well, this one is upside down, and we can get that as well. It's going to be negative x squared minus 4x plus 5. This factorizes to negative x minus 2 all squared plus 1, so it's 2 and negative 1. That should be 2 and negative 1. So the range for that one there should be negative 1 to infinity, because it continues. Negative 1 to infinity, negative 1 is included because the smallest number is there. Do that. I can't do B, I'll run out of room there. Same with this one here, x squared plus 3. Now x squared plus 3, it's going to be shifted up. So we're going to do it 3, so this is it here. Okay, but we only want it between the x values of negative 1. So if I put negative 1 in there, negative 1 squared is 1 plus 1. So that stops there at 4. And 1, it stops there at 4. So this is 1, 4. This is negative 1, 4. So just rub that graph out because I can't have it like that. I've got to have it like this. There we go. It stops there. So the domain is that one, but the range is only going to be, the lowest value is here at 0, 3. So from 3 to 4 inclusive. So be careful with that one. Okay. If there's no written domain, then we take as the biggest possible domain there is, which is called the maximal implied domain. So again, we just sketch the graph and we work it out. So this is a circle, I can tell, because they're both squared and inside. So I find my center, the x center, I'll put it equal to 0, I get a half. The y center is going to be 4 divided by 2, 2. So the circle is a half. X is a half, which is right there, and y is 2. There's my center, but then the radius is 1, so it's going to go up here, so that's going to be 3, down, so it's 1 there, across, this will be 1.5, and then across, which will be at a half, x value of a half. So when I do that one, so the circle is actually like this, so the range here is going to be from 1 to 3, inclusive, and the domain is going to be from the negative a half to 1.5, 3 on 2, inclusive. And this one here, we already know this is shifted up 3 because we know what the graph looks like. There's an asymptote there. And 5 divided by 2 is 2.5. So x equals 2.5. 5 divided by 2. So the graph looks like this. Okay, it's irrelevant. The domain is reals, except the x value of 5 on 2, domain, reals, except the asymptote, which is 5 on 2. And the range here is all the reals, except, again, the asymptote, which is 3.